So we've just covered classes, and now we're going to continue with classes, but we're going to do some more things with them. So let's recap first what we've done the last time. And so up here, this is the basic code that we used from last time. And up here we have the general structure of a class definition. So we start with the keyword class, and then we put in a class name. After that, it's followed by a colon. And then below it, on new lines, we write in properties of the class, and these are all indented to indicate that they're part of the class. So here, for example, we've defined an initializer for the class. So this, when you create the class, this automatically sets the attributes, or at least some of the attributes. And we see here, to define an initializer, it's just like defining a function. We use the def keyword, and then since the initializer already exists, we actually have to override it. But we will come back to this, so don't worry about this that much. Just remember the syntax, that we have two underscores, then we write init, and then we have another two underscores. And since it's very similar to functions too, or since they pretty much are functions, we have to have open and close parentheses afterwards. And inside of these open and close parentheses, we have to put the self, and this lets the class interact with itself, so this indicates that it can be part of the class. And then we have our colon, and on a new line indented in this function, or in this method, since it's in a class, are some actions. So in this case, we just set the attribute that belongs to the class, so the self.attribute, to 0. And then we go out of this method, or this function, and we create a new function called another function. And here again, we have the open and close parentheses afterwards, and we also have to put on the self. So this is just since we're dealing with classes. And then we have the colons again, and on a new line, we have some action or some actions that we do. And so this is kind of the general structure of the class. Then we've created our own class, and that class is called team. And so we created the class using the class keyword, and then we defined the class name, which is team. And then we have our colon here, and on the next line, we are indented, and we've defined the initializer using the def keyword, and then the two underscores, init two underscores. And then we open and close parentheses. And inside here, first we have the self that we see. And then we also have some other variables that can be put in. So for example, a name can be put in. And what we've done here is we've set, if no name is put in, we've made the default name, name. And an origin can also be put in. But if there's no origin entered, then the default origin is origin. And then we enter the initializer, and what we do is we create the attribute team name, which is part of the class, and we assign it the value name, so the name that's entered in the team. And we also create the attribute team origin, and this we assign the value of the origin that's entered here in the initializer. And then we've created two other functions, or rather two other methods. So the first one we've created was the define team name. So again, the structure is very similar to functions. We have the def keyword. All of this is inside the class though. So we have the def keyword, then the function or method name. In this case, it's define team name is the name of our method. And then we open and close parentheses, and we include the self here since we're in a class. And then we also include a name that we're gonna change, or that's gonna be part of the input. And then we have our colon here, and inside of this method declaration or function declaration, we change the team name attribute of the class, and we change it to be the name that's inputted here, or that's the input of this method. And then we have another function called the define team origin, and here once again we have the self variable as well as the origin. And here we change the team origin, that's the attribute of the team, and we make it equal to a new origin that we put in here. So this is kind of a basic class that lets us define a general team, and we give them a name, so the teams have a name, and it also lets us give them an origin. And it also lets us change the team name as well as the team origin. So let's expand on this a little bit. So right now we're just dealing with a general team, but every team should have players. So let's make another class, and this time we'll make a class players, and this class players is going to be related to the team in some sense. And so let's go over an abstract version first. So what we're going to do is something called class inheritance. But what that means is the new class that we're going to be making is a subsection of the bigger class, or it's kind of like a sub part of the bigger class. So every team has players, so player is part of the bigger team class. But let's just write out an abstract method so that we can kind of refer back to it, and then we're going to have some actual implementation so that we can see it in action. But to define an abstract class, we have to we just start with the keyword class again, or to define inheritance class abstractly, we start with the keyword class like usual, and then we have inheritance class name, and then we open and close parentheses after this one, which we didn't do up here. And what we put in here is we put in here the parent class, we can call it. So the class that we're going to be inheriting parts of. So in the case of the player, for example, the parent class would be the team. So this is just kind of the next level, the class that's one above the one that we have here. And so don't worry if the abstract thing is a little bit weird, but we'll just leave it up here just for reference later. And then here we can once again define an initializer, for example, def, and then we do the double underscore init, a double underscore, and then here we again put self and some input 1 and maybe some input 2. Yeah, and then here we have our colon again. And then what we do in here is, since we're part of the parent class, what we do is we call the parent class, like so, and then from it we have to call the initializer. So we go double underscore init, and then double underscore, and then we just have to put in the self keyword. So what are we doing here? Well, what we're doing here is, since our inheritance class, so our subclass inherits some properties from the parent class, or parts of it are from the parent class, we also have to create the parent class, and so we have to initialize it. But since we're in the initializer, when we do def init here, we're in the initializer of the inheritance class. So we actually have to call the initializer of the parent class. And don't worry, you will see some actual practical examples of this, but let's just, like I said before, we'll just keep this here just for kind of reference or for completeness. So we have to initialize the parent class. So we go into the parent class, and here we call the initializer with certain values. So in this case, we'll just call it with self. And then we assign self some attribute 1 to be equal to maybe the input 1. And then we create a second attribute, so attribute 2, and we'll make this one be equal to the input 2. Like so. So very similar to here, we've just created 2 attributes now. It doesn't matter how many there are, and we've made the first attribute be equal to the first input. We've made the second attribute be equal to the second input. These attributes are attributes of the inheritance class. They're not part of the parent class. And I mean, we can add a third attribute, for example, so we don't have to rely on this input. We can do a self.attribute3, for example, and we can make this one be equal to 0. So we don't just have to rely on the input, but here we can also declare or initialize all of our attributes and give them a certain value that we want them to have. Yeah, and then we can go down and we can define an inheritance class method. So we can just define here another method, and then we open and close parentheses since it's very similar to the function definition. And in here we put in the self keyword since we're in a class, and then we have to put the colon since it's very similar to a function declaration. And then we have some action or some actions. And so here we've defined another method. So very similar to defining the original class in a sense, that we create an initializer and we always have the self keyword included afterwards in the parentheses. Here we've made the attribute of the class equal to 0. Here we've created 3 attributes. You don't have to create 3 attributes, it's just an example. So here we've created attribute 1, and we've made that equal to the first input. We've created attribute 2, which is equal to the second input, and we've created attribute 3, which is equal to 0. And these attributes are all part of the inheritance class of here. And what we've done here is we've also initialized the parent class. So since our inheritance class inherits some properties of the parent class, so it gets some properties of the parent class, we also have to initialize it. And then down here we've just defined another method, just like we've done up here, and we just used the self keyword, and this method is also part of the inheritance class. Yeah. So let's comment this out though. And let's apply this to do something practical with it. So let's create the class player that's part of the team. So we'll use our class keyword, and then we'll type in the name of the class, which is going to be player. So now we're creating a class player, and now since we want to inherit some properties from the team, or since the player is going to be part of the team, we have to open and close parentheses, and inside of these parentheses we just put the name of the parent class, or the name of the class that this class is going to have properties from, or that this class is going to be in. So our player is going to be part of the team, and so it's going to inherit some properties from the team. Yeah, and then we just continue normally, and we do the colon to indicate that we want to start the class definition. And then on the next line, we define the initializer. So we initialize the player class, and so we do our double underscore, and we type in init, and we do another double underscore. And then we open and close parentheses afterwards. And then here we'll put in self. And here we can also have some different attributes. Let's leave this blank for now, but we'll deal with this later too. So we'll add some more attributes here, but let's leave this blank for now. And we'll just define our initializer, and then we'll do this with a colon again, and then inside the initializer, we first initialize the team. So we call the team, or we go into the team class up here, and we just call the initializer here. So the double underscore init double underscore, and open and close parentheses. And since we've given the option for our name and origin to have default values, we don't have to put something in here. If we don't have default values given here, so if there wasn't any equals name and equals origin, then we would have to put some values in here. But we don't have to do that right now. So all we have to put in here is just self, since it's part of a class. And then let's create some attributes of the player. So let's create a player name. So self.player name. So what we're doing is we're creating a player name, or a variable player name, but since it's in the self dot, this player name is actually going to be an attribute of the player class. And let's just initially make this player name equal to none. So there's no name right now. And let's also have another attribute called player points. So the points that the player has scored. So we'll go into the self, and we'll make the attribute player points. And let's say that originally every player starts with 0 points. So what we've done here is we've created a class player, and this class player is part of a team, or inherits some properties of the team. And then we initialize the player, and we remember that we have the self in here. And then since we're initializing the player, and the player is part of the team, we also have to initialize the team. So we call the team dot, and here inside the team we call the initializing method, and we just put in self. And since we have default values for name and origin, we actually don't have to put anything in here. If there wasn't the equals name and equals origin here, then we would have to put in some more values, but we don't have to do that right now. And then we have we create a new player attribute, or an attribute for the player, which is the player name, and initially it's none. And we also create the attribute player points, which initially is 0. And then let's make a function or a method for this player class, and let's call it scored point. So we'll create our function or our method with the def keyword inside of our class, and the method name is going to be scored point. And we're not going to really have any input except for the self, so we're just going to assume the point that was scored is always worth 1 point, and we can change this later too. But right now let's just start off simple. And so we define a scored point method, and it has the self keyword since it's part of the class, and then we have the colon. And then inside here, what we do is we just increment the player points by 1. So we access the player points, so the self.player points, and what we do is we increment it by 1, so plus equals 1. So what we do is we take the player points attribute that's part of the class, so here we have the self keyword, and we add 1 to it. So that's what the plus equals 1 does. It adds 1 to the player points, or it increments it by 1. And then let's also make another method called name. So we'll use this method to name the player, or let's make it set name. So we'll define the method and we'll call it set name, and we'll open and close the parentheses, and inside here we'll put in our self keyword, but we also need to provide a name now since we actually want to set the name to something specific. So inside, when we call the set name method or the set name function that's part of the player, we also want to provide a name so that we can set the name of the player. And then to set the name of the player, we have to access the player name attribute. So we type in self.player name. So we access the player name attribute and we make it equal to the name that we put here in the input. And so this player name and these player points and everything, they're very, very similar to variables. The only reason we have to add the self dot here is since we're part of a class, or since this is an attribute of the class. Now, if we weren't inside a class, this would look really familiar because all we're doing is we're setting the player name variable equal to the name. And that's pretty much exactly what we're doing now. It's just that we have to add the self dot keyword because the player name variable is going to be an attribute of the player class. So it's part of the player class. But it's very, very similar to assigning values to variables that we've dealt with before a lot of times. So you can kind of think of the similarity there and help that to kind of better understand and this self dot kind of feature. Yeah, so let's just leave it at this for now. And then later on we'll go into it again and we'll create some extra features. So let's just create a player. So how are we going to create a player? Well, the way we're going to create a player is we'll just call it player 1. So we'll have player 1, and we're going to have player 1 be equal to, and then we call the player class, and we open and close parentheses. And even though it says team in here, this means that this part of a team, or that the player is part of a team. We actually don't have to put a team class in here. So this would work without a team class in here. This, when we define a class and when we define inheritance, so when we define a class that's going to be a subpart of another class, we don't have to put that inside of these parentheses. So let's just see this. And let's just print out the player name and print out the player points. And then let's go through it again. So we'll print out the player 1, so we'll access player 1, and we're going to print out their player name. So what are we doing? We're going into player 1, which is the class player, or which is a class player, and inside of this player1, so inside of this player class, we access the variable or the attribute player name, and we're going to print that out. So we're going to print out the player name. And then on the next line, let's just print out the player points. So we use the print function, and we access player1, or we want to get the player points from player1, and then we put the dot to indicate that we're going to access it or do something to it. And then here we'll put in the player points. And so let's just run this, and then let's go through it again. Okay, so we see here we print none. So this comes from the player1.playerName. So when we create player1, what we do is we create a class called player. And when we create a class called player, we give player name the default value none, and we give player points the default value 0. And so our player1 has default value or default name none and default points 0. So we can access the player name here. We can also access the player points of the class, and it's going to print out the player name, which is none, and it's going to print out the player points, which is 0. Now, something else that's cool that we can do, and here you'll really understand the point of inheritance, is that we can also access the attributes and the functions of the class above it. So we can access the team class too. Since the player is part of a team, maybe we want to know what part, or which team he's in or she's in. So we want to access the team name. So let's print out. And then in player1, we're going to access the team name. And we'll cover this again in a second. So we want to really understand what's going on and why we can do this. But let's also print out here player1. So we're accessing player1, and here we want to print out the team origin. Okay, so let's run this and let's see what we get, and then let's understand why we get this and why it works and what's going on. So we get our player name, which is the default name, which is none. We get the player points, which is the default points, which is 0, which we define up here. We get the team name, which is the default name, because here we initialize the team inside of the player. And so let's see, we call inside the team, we call the init function. So let's go up to the team and see what the initializer function does, or initializer method. And what it does is it sets the self.teamName to name, and it sets the self.teamOrigin to origin. So what is name and origin? Well, since we didn't provide a name or an origin here, the name and the origin are going to take on the default values, since that's what we told it to do. The default values are name and origin. And so our player has the attributes of player name and player points, but it also has the attributes of the team. So the player is also part of the team, and therefore the player also has the attribute team name, and it also has the attribute team origin. And now what we can do, for example, is we can also change the team name by accessing the method in team. So this inheritance lets us access all the new functions that we've created here, or all the new methods, but it also lets us use all of the old methods that we've created before. And so this makes sense, since some classes or some objects or some creations may have certain properties that other more general objects have. So in this case, a player, for example, has all the attributes of a team plus their own attributes. Something else that you could think of is that a dog, for example, would have all the attributes of a pet plus their own attributes. And so a cat would also have all the attributes of a pet, but they would also have their own attributes. And so there are, you can think of it like that. So that there's going to be a general class above that has general attributes, and then there are going to be kind of subclasses of this, or like subsections, or elements that are part of this class in some sense, that have their own special attribute. And that's where you use the inheritance from. If you feel like the class that you're creating also has all the attributes of another class, but it's a more specific part of that class, then you can use inheritance here. And so what we've done is we've created a player that's part of a team, and the player also has all the properties of the team. Since the player is part of a team, it also has, or the player also has a team name since they're part of a team, and the player also has a team origin since they're part of a team. But the player also has its own player's name and their own player's points, so how many points they've scored individually, which is not shared among the team. So let's run this first, and then let's run this again so we see here. And now let's change the team origin first, and let's do that using the player 1. So we can go into player 1, and you'll notice we never actually created a team here. We've implicitly, or we have created a team inside of the initializer, but outside in our code we've only created a player. But inside the player, since the player is part of a team, inside of the player, inside the initializer, we've also created a team. And so this is the team that the player is in. And so here we can do player 1, and what we're going to do is we're going to define the team name. So we're going to call the define team name method or function, and then we'll do open and close parentheses. And here let's put in the team name sharks. So what we're doing is inside player 1, we're accessing the define team name function that we've created up here, and we're putting in the name, which is going to be sharks. So if we run this, then we see that now we've changed the name to be sharks rather than the default value, so we can also interact with the properties of the team, just like we've done here. And now maybe let's go about changing our initializer so that we also have the ability to enter name and origin and player name and maybe player points. So maybe the player has already scored some points but hasn't really been registered yet and is going to be added to the team later, or maybe the player is being transferred or something. So let's make all these attributes part of the initializer. So let's add another input, and let's have this input be player name, and then also let's add here the player points, and let's also add here the team name and the team origin. And so when we call the team initializer, now we can use the input that we've created up here of the team name and the team origin inside of this function. So let's write it in first, and then let's understand what we're doing. So inside here, we can put the team name, and we can put the team origin. So what are we doing? Well, let's just write this all out explicitly so that we can follow along what we're doing. So what we're doing is we've given ourselves the option to put in a player name here, or right now it's mandatory since we're not assigning default values, so we have to put in a player name. So let's put in the player name Sid, and the player points 0. So just like calling a function, we separate our input by commas. So the player name is Sid. Remember, even though it says self here, it's never actually part of the input. So we put in Sid, and the player points is 0. The team name, let's make it be Sharks. And the team origin, let's have it be Chicago again. So we've got kind of competing teams or something, or competing, players. And so we can just maybe take out this line for now. And so what we're doing here is when we call the player, and now we put in a player name and player points and a team name and a team origin. And this is what we initialize with. And now we can access all of these values inside of our initializer. And so when we call the team initializer, we can use the input from here. And since up here in our team initializer we also have it's an option here because we have optional values of providing a name and an origin. Here we actually provide the team name and the team origin now, and so our values are no longer going to take on the default values. So when we call the team.init, and here we provide name is going to be team name, and the origin is going to be the team origin. So now our team is actually going to take on a specific team name that we specify here, and a specific team origin. And then our player name, we can change that now. Rather than being none, we can change that to be equal to the player name. And our player points can be equal to the player points. And so these names don't have to be identical. So player points here doesn't have to be identical to this. So this could, for example, also be p points, so short for player points, and we can put that here. It doesn't have to be identical. It just you just kind of write it like that because it fits. It accurately describes what you're putting in. But if it's a little bit confusing or something, you can also change the name as long as you know what you're dealing with. So let's run the code and let's see what we get now. So now we run the code and we've created our player, and the player's name is Sid. They've scored 0 points. They're part of the team that's called Sharks, and they're from Chicago, or the team is from Chicago. And so when we print the player name from player 1, we print the name here, Sid. When we print the player points, we print 0. When we print the team name, we get Sharks, and when we print the team origin, we get Chicago. So now we've changed from the default values, and we've moved on to more specific values. And we've created a player class that inherits properties of the team and can deal with both. And so what we can do, for example, is let's have the player score a point. So at the bottom, let's call player 1, and here let's have them score a point. So player 1 dot, and then scored point. So we're accessing the scored point method inside. And since it's a method or a function, we have to open and close the parentheses behind. So here we're accessing attributes, or we're accessing variables, and so we don't have to put the open and close parentheses. But here we're accessing functions, or we're accessing methods, and so we do have to put the open and close parentheses. And since there's no input here except for points, except for self, we don't have to put any input here. And then afterwards, let's just print player 1's points again now. So we go into player 1, and we print the player points. So here again we see we don't have the open close parentheses because it's an attribute or a variable, and here we do because it's a method or a function. So let's run this and see what we get. So we see that our player is called Sid. They've scored 0 points. They're in the team that's called Sharks. The team is from Chicago. Now they've scored a point. And now, when we print out the new points, we see that they've scored a point here. So here we've used the team. We've used a lot of the capabilities of the player class. We haven't really used the set name, but we've provided the option, and it would work very similar to the defined team name. So if you want to change the name, we can just go here. Maybe let's go on a new line, and let's change the player name. So we go into player 1, and we access the method set name, and we put in a new name here. So set name, and let's have it be Lee. And yeah, so now we've changed player 1's name to Lee, because when we call set name in player 1 with the input Lee, what happens is our player name gets changed to the name that we put in here. So in this case, our player name gets changed to Lee. And so if we print out player 1's new name, so player 1, and then we access the attribute player name, and when we run the code again, we'll see that the name starts off as Sid with 0 points, part of the team Sharks from Chicago. Then they scored a point, since we called the player 1 and the scored point methods, that's part of player 1. So they scored a point. And now we call in player 1, we call the set name method, which changes the name to the name that we put in here. And now when we print the new name, we get Lee. So here we print the new name, and we get Lee. And up here we print the initial name, and we get Sid. So cool. Now we can see that we can access both methods and both attributes of the inheritance class, which in this case is player, and the parent class, which is the team. So we can interact with both of them, since the player contains all the attributes that the team offers or has. Let's add one more cool function. And so we want to be able to call print on player 1, and we want to get a certain output for that. So let's be able to just print player 1 rather than accessing the individual names, and we'll see what that means. But yeah, so we'll just define, and then we're going to be able to use the print function on player 1, but we'll just write it down first and then we'll see. So we go def, and then we go double underscore. So what this means is we're going to be overriding something, and what we're going to be overriding is the str. So this kind of the string. And then we go double underscore again. So just like by init here, we're overriding the initializer. Here we're overriding the str, or the string. And we open and close parentheses, and we'll just put in self, since we're accessing the class. And now what we're going to do here is we're going to return something. And so what we're going to return is we'll just put in a sentence. So actually, we'll just return, and what we'll return is player has scored, and then we'll put in a colon and a space, and then plus, then we'll access the player points plus the string. So we have to make the player points a string. So we'll put the self dot player points. So what we're doing is we're going to return something. We're going to return the string player has scored, and then we're going to add to this the player points, but we have to make it a string since this is all part of a string. And otherwise, the plus method means something different for integers and for strings. So we put in here plus this string of player points. And so this is just what we're going to return. And then maybe we add here plus, and then we write in here points. So what we've written is, or what we're returning is, the player has scored, and then we add here the player points, and we have to use the self, since we're accessing part of the class, and then we add here points. So we're going to write the player has scored, and then however many points, and then we just write points. So how do we call this, or what does this do? Well, if we call the print, then we can call the print on player 1 like this. So we can just call it on player 1 without adding anything special here, like we don't have to print a certain attribute like the player name or something. What this does here, what the double underscore str double underscore, what the override does here is that it allows us to call the print on player 1, and it allows us to return, or so we give back, a certain message. So if we run it, we see all the stuff that we've had before. So we've created the initial class with name Sid, 0 points, part of the Team Sharks from Chicago. Then they scored a point. We changed the name to Lee. And then we call the print on player 1, and we print a custom message. And this custom message is the player has scored 1 point. We can change this, for example, to make it even more specific, and add the player name in the front here. So we can add self.player name, and then we add here, and then we put a space here for formatting. And since the player name is going to be a string, or we assume it to be a string, we don't have to do this str conversion that we have to do for the integer. And so here we just return the self.player name plus has scored, so we'll have the name and then the space here for formatting has scored, and then we'll return the points. And here we have to change it to a string since the points are an integer, and the plus means something different for integers and for strings. And then we print out points. So let's see this in action. So here we see all the stuff from above, and then we have Lee, which is the player name, has scored, and then we print out how many points they scored, points. And so this override allows us to return a specific output, and we can use that to return the information that would best fit whatever would happen if you want to print it. So if you want to print player 1, you want to know as much about the player or about player 1 as necessary, or you want to give something back that provides all the necessary information or a good amount. And you want to be able to provide back custom output, not just wait until people or until player 1 calls or until someone calls the player name from player 1 to check the name and such. And you don't want to have people have to create their own combinations of everything, so that you don't want them to have to create their own sentences that contain the player name and the origin and points and all that stuff. You want to be able to give back custom output that best represents what the player 1 is currently at. And so that's what we can also do here with the overriding the string or the str method. And we just return the custom output that we've created here.